Okay. So are you able to hear me? Okay. So I told you in the previous sessions also the quiz distribution, the final quiz will be having some 20 questions, and out of these 20 questions from week 1 to 8 there will be 8
Sir,
questions. Yeah.
your screen is not visible.
Okay. Is it visible now?
Yes, sir.
Okay. So what I was saying, out of in the final quiz, you'll be having 20 question. From week 1 to 8, you'll be having 8 question, one question per week, and then from week 9 to 12, you'll be having 3 questions per week. So altogether, you'll be having 20 questions, right? And you can just think of as the weightage also out of this, right? So your last 4 week is the most important, and then the that is like mostly the Fourier transform and the Laplace transform. Okay, those are the most important portions for your final quiz paper. So we'll try to solve some problem from the Laplace today. Okay, and then the remaining portions we'll try to discuss. Maybe I'll discuss some of the portions from the systems also, signals also, the basic idea, some problem, and then the remaining we'll be discussing on the Wednesday session. So let's try. So I have given you the weightage also. So you have to try focusing more on Fourier transform, the Laplace transform. Okay. Okay. So let's start with one problem. So initial value theorem and the final value theorem. I hope you must be knowing as of now because that is important for you guys. Okay. Uh, so if I'm asking, the question is given in such a way that you have been given the transfer function or the impulse response. Let's for example the impulse response has been given to you. Okay, that is 10 minus is upon 10 is plus 1. Now if you have been asked to calculate t0 and t infinite, how will you calculate? This is the first simple question. You have been given the impulse response and then you have been asked to calculate the initial and the final value of the impulse response. So here you have just been asked to calculate the initial value and the final value of the impulse response itself. I hope you must be knowing that. How do you calculate that? You calculate it limit x tends to infinite s times t of s. Correct? Similarly, limit s tends to 0 s times t of s. So if you have to calculate t0, the t0 will be s times 10 minus, sorry, whatever the value that you'll be getting. Okay, so you'll be getting something s times 10 minus s and 10 s plus 1. So whatever the value that you'll be getting, that will be your initial value, and the final value, if you have to calculate, put the value of s equals to 0. Okay, this is a simple case where you just been given impulse response itself. Okay, and then you have been asked to calculate initial value and the final value. Now you can be asked, the initial impulse response will be given to you. This is the impulse response, but you will be asked to calculate the initial value and the final value of the step response. So impulse response has been given, but you will be asked to calculate for a step response. So initial value and final value for step response. How will you calculate this? How will you calculate this? initial and the final value of the step response? See, step response, first you should be having the equation, the first impulse step response, right? So how will you calculate step response? See, any equation has been given ht, and if you are giving some input xt as ut, so in the Laplace domain, what will be the value? Hs times us. So you have the impulse response, right? So 10 of 10 minus s times 10 of s plus 1 times 1 upon s. Okay, now this will be the original function for you. And now if you have to calculate the step response, what can you do? Multiply s here and then limit s tends to infinite for initial condition. And for the final condition, what will you do? The same thing, 10 minus s, 10 of s plus 1 times 1 upon s. Okay, multiply with s and then limit s tends to 0. Okay, this is how you calculate the value. Is it clear to everyone? So this is initial and the final value for the impulse response. This is for the step response. I hope this is clear. Okay. Now, so from the Laplace transform itself, I hope the partial. Okay, let's do one more questions. Where, let's for example, you have been given the pole zero plot has been given to you. Pole zero plot has been given to you. Okay, so it has been given. This is how will you calculate the value of the Hs if you have been given the pole zero? How do you calculate that? So see, the circle that has been given to you is a 0, and these are the cross are the poles. How will you calculate the Laplace the if you have been given the pole zero plot of the Laplace transform, how will you get the function, the mathematical equation of that?
Poles upon 0.
Poles
Poles upon 0.
0 upon poles, right? So all the equation, what are the zeros? So zeros are what? 5. So s plus 5. Poles are what? 1 is 3. So s minus 3 times this one, right? S minus whatever the equation that you are getting, minus 1 plus j2 times s of minus 1 minus j2. Is it clear to everyone? So this is minus 1, right? So here it will be plus. So this will be the equation, the mathematical equation of your this. If the pole zero plot has been given to you, this is how generally you calculate the equation, the mathematical equation. I hope this is clear to everyone, right? Okay. Yeah. So if we have been given the question like not directly has been given to you. It has been given, and you have to do partial fraction. I hope you must be knowing. So let's, for example, the question that has been given to you is, and whatever the question that I'm dealing for the Laplace transform, if you know that, like, if you are able to solve all these questions, you will not be facing any problem in the exam also. Okay, so initial value final value theorem I already did, right? So one more problem, you can just try it out at your home. 2s plus 5 s square plus 5s plus 6, you have to calculate. This is here, nothing has been given, you just have to calculate s0 and s infinite. If nothing has been given, like whether you have to calculate the step response of this Laplace or whatever, so here it just when if it's just not been given that you have to calculate x0 and x infinite, then you can directly calculate it as limit s tends to infinite, this is x0, and this is how generally you calculate. This is very simple to calculate. Okay. Okay. Now, the next problem is, if you have been given the question, something like okay. So the initial value final value theorem is done. Okay, so okay, one more thing. Have you learned about that? Where the if your whatever the impulse response has been given to you or a system has been given, you are putting the input that you are giving is some sinusoidal or exponential function. What will be the output? Those things, have you dealt with that or not? Okay, so let's say example, you have been given a signal. Let's say example yt has been given to you. That is x1 times t minus 2 convolution of x2 times t plus 3. You have been given x1 minus 2t ut. You have been given x2 as minus 3t ut. You have to calculate transform, the Laplace transform of this one yt. How will you calculate? This is very simple, right? What you have to do is take the Laplace transform of this x1, take Laplace transform of x2, and then multiply both. Correct? Because anything in the time domain, if the time domain is convolution, right? The Laplace domain, what will happen? It will be in the form of a multiplication. Okay. And now you have to calculate the ROC also. Ys you have to calculate with ROC. So ROC also you have to take care. What will you do? See, for x1t, you have to do that. You already know that for x1, if you know the Laplace transform for x1 t minus 2, you can directly calculate the Laplace transform. So anything that you are delaying here in the time domain, you'll just multiply the exponential thing in the frequency domain. I hope you're already knowing that. So what if you have to get the Laplace transform of e to the power minus 2t? So what is the Laplace transform of e to the power minus 2t? That is 1 upon s plus 2. But you have a time shifting t minus 2. So that for that you will be multiplying something e to the power minus 2s. Correct? Similarly for x2 also, you already know that the Laplace transform will be 1 upon s plus 3. But you will be multiplying what? Because of this time shifting, right? You will be multiplying e to the power 3s here. and this will be in the form of a multiplication to get the ys. Is it making sense to you guys? Yeah. So, but one more thing, we have to calculate the ROC also. So for this case, what will be the ROC? Sigma greater than minus 2. And here it will be sigma greater than 3, minus 3. Correct? And then you can multiply it to get the value. So the whole ROC for this ys will be what? One is sigma greater than minus 3, one is sigma greater than minus 2. So the whole ROC will be sigma greater than minus 2. You just have to multiply this, you will be getting the ys. If, let's for example, you have been asked to calculate the yt also, then you can take the inverse of this sigma. Yt as like yt, mostly you already calculated from the yt itself, the Laplace transform. There is no chance that you will be asked to calculate the yt. But let's for example, if you have, because there is a some shifting also. One more thing, can you tell me whether this system is causal or non-causal? The ys that you have calculated, whether this is a non-causal or causal? We have already dealt, right? Because this is non-causal, right? So for causal, for any system to be a causal, for t less than 0, the ht should be 0, right? But here it's not, right? For this defined for some less than t also. Okay, so that's why it will not be a causal. It will not be causal. Yeah, it will be a non-causal system. Okay, it will be a stable because sigma is including j omega. Okay, so that's why the system will be stable. These all things we have already discussed in the previous session. Correct? Okay. Now, and for the partial thing also, so you'll be asked to calculate the Laplace or the Laplace inverse. Let's for example, the Laplace transform has been given to you, like 20 upon s plus 3 and s square plus 8s plus 25. How will you calculate the Laplace transform? How will you calculate the Laplace transform? So you have to use the concept of the partial fraction, right? So how will you do that? So this you can just split it as a upon s plus 3 plus bs plus c s square plus 8s plus 25. Okay, and then you can compare it. So you can get the value of a directly. A, you can just put it as the whole function s equals to minus 3. Okay, removing this, so whatever the value, so let's for example the value will be getting as 20 upon minus 3 whole square minus 24 plus 25. So you'll be having 20 upon 10. So a you are getting as 2. So you'll be having what? 2 upon s plus 3 plus bs plus c upon s square plus 8s plus 25. Then you will have to compare it. So if you will compare it, you'll be getting what? 2 times s square plus 8s plus 25 plus s plus 3 times bs plus c. Okay, and that should be equals to what? 20. Okay, so now if you will compare it, you'll get some values. So whatever the values that you are getting, let's for example any values that you got, okay, let's compare it. So you'll be getting 20. Okay, so here you'll be getting, so let's put it as a itself. As of now we already know the value of a. So you'll be getting 25. If you'll just put s equals to 0, what will you get? 25 times a plus 3c equals to 20. Let's put s equals to 1. Let's put s equals to 1, you'll be getting 34, right? 25, 8, so 34 a plus b plus c times 4 equals to 20. So put a equals to 2. So you'll be getting c equals to minus 10. Here also you put a equals to 2 and c equals to minus 10. So if you put it c equals to minus 10 here, you'll be getting b equals to minus 2. Now you have the equation. So your equation will change to 2 upon s plus 3 plus minus 2s minus 10 upon s square plus 8s plus 25. Okay, so your equation will get changed into 2 upon s plus 3 minus 2 times s plus 5, s square plus 8s plus 25. Is it clear to everyone? Are you able to understand, or you're just anyone? Okay. So now from here, how will you solve this? So for this equation, you already know how to calculate the inverse. But for this, you have to take care, because see, this quadratic equation you are not able to solve it. So that's why we have a split. Like you are not able to split it. Like, so you have to take care. How will you split this? So this is something like
It's
what?
2 into e power minus 3t.
What?
So the term 2y s plus 3 will become 2 into e to the power minus 3t.
Correct. So yeah, this term will become 2 into e to the power minus 3t ut. But for this term, you have to take care of this term as this is minus 2 times s plus 5. The denominator part, what you can do is, this is what, if you'll just think of, this is something like, if you'll just split it, this is s square plus some 16 plus 9 plus 2 times 4 times s, right? So this is, so if you'll just think of, this is like something like 2 s plus 5 upon s plus 4 का whole square plus 9, correct? So from here you can get an idea, right? This is something like what? This is some form of the Laplace of sine or cos. Here also you are not getting, see, because here also you should have got s plus 4. So split it this. So if you will split this, it will be 2 times s plus 4, and then 1 is 1 will go here, right? So minus 2 times s plus 4 का whole square plus 9, and here it will be s plus 4 का whole square plus 9, correct? And here we were having 2 times e to the power minus 3t ut. So for this, what will be the Laplace inverse? This cos, right?
Yes, sir.
Correct. So here will be, and cos with the shifting, right? S plus 4. So you'll be having e to the power minus 4t. 2 times e to the power minus 4t cos of 3t ut. So 2 times e to the power minus 3t ut. Now the second case will be what? The second case will be e to the power again.
Sine form.
Here it should have been what? Here it should have been omega square, right? 3k square. So you'll have to divide it by 3, correct? So it will be 3 square. So 2 upon 9 to the power minus 40 sine 3t ut. Sorry, here it should be omega, right? Only. So omega, you need what? 3. So here it should be 3 upon 3. So the whole equation, the Laplace inverse will be 2 minus 3t ut minus 2 times e to the power minus 40 cos 3t ut minus 2 by 3 minus 40 sine 3t ut. Is it clear? See here what we have done. So for sine, what do you get? You get what? Omega upon s square plus omega square, right? Correct? For cos you got s upon s square plus omega square. So here omega was not there. So we just multiplied 3 in the numerator side and denominator side. So we got it like this equation. Clear?
Yes, sir.
Yeah. So and similarly, if so, this was a bit difficult. Let's for example, you have a Laplace transform. You have been given something like that: s square plus 12 upon s times s plus 2 s times plus 3. Now, and the sigma is already given to you minus 3 to minus 2. You have to calculate the Laplace inverse. So this is pretty simple, right? You can just write it as a upon s plus b upon s plus 2 plus c upon s plus 3. Correct? And then you can get the value of a. You can get it by putting s equals to 0. So if you put s equals to 0, what will you get? 2. You're getting 2. So 2 upon s. Similarly, b you can get it by putting x equals to minus 2. If you'll put it, you'll get b equals to minus 8. Minus 8 by s plus 2. Similarly, if you'll put c s equals to minus 3. If you'll put it here, you'll be getting c equals to c minus 7. Right? 7 upon s plus 3. So now, if you get this, you can directly get the impulse response, right? But okay, so and ROC has been given to you already. Sigma should be from minus 3 to minus 2. So here, for this equation, you'll be getting what? What will be the getting the Laplace inverse? Because see, I already told you it all depends on the ROC. So if your ROC is minus 3 to minus 2, so your ROC you should be taking, like, you can't directly write it as e to the power minus 2t ut, because if you put it like this, your sigma will be greater than minus 2, but here all the things should be from minus 3 to minus 2 only. Okay, so what you will be doing is you will be taking the left hand side wala thing. So the Laplace, so for this case, for 2 upon s also, you can't take u of t, you take u of minus t, so that the sigma will be less than 0. Are you getting me? So the Laplace inverse of this will be minus 2 times u of minus t. Similarly, for Laplace inverse of this case will be what? Here it is minus 8, so minus minus will get plus, so plus e to the power minus 2t and u of minus t, because everything you need in the left hand side only. And then for this case also, for this case it will be minus of 7 e to the power minus 3t u of minus t. Now if you will see that the Laplace, the ROC for this case is what? So this is a hit and trial. So let's for example calculate the ROC, whether you are getting the ROC as same as this or not. So let's see. So for this, what will be the ROC? Minus 3. For this case, it will be sigma less than 0, sigma less than minus 2. Okay. So but for the whole case, you are getting the sigma as less than minus 3. But this is not a correct like inverse, because you need what? You need the ROC as minus 3 to minus 2. So something you have to do. What we can do is we can take the Laplace inverse of this case as the other, like the other case, the right hand side wala. Okay, so if you'll say take it, the Laplace inverse of right hand side, so it will be what, plus 7 times e to the power minus 3t ut. So for this the ROC will be what, the ROC will be sigma greater than minus 3. Correct. Now if you see the ROC, so one is sigma greater than minus 3, the other is less than minus 2, the other is minus 0. So now this is the common area, right? So now for this case, this is the answer for us, because the ROC that was required was from minus 3 to minus 2. Okay, so that's why we have taken this. So it's like a hit and run. So earlier what we did is we have taken the left hand side, but while taking the left hand side we were getting that the sigma was less than minus 3, the ROC was totally less than minus 3, but that was not the case for us. For this question we were needing the sigma that was in the middle of minus 3 to minus 2. Is it making sense?
Yes, sir.
Okay. Okay. So now the next problem is, let's for example you have been given to calculate the Laplace transform of a function Laplace inverse of s plus 5 and s plus 6. How will you calculate this? How will you calculate xt? See, here you have to use the properties. So we have dealt with so many properties of differentiation property. You can use it here. See, this equation is what, ln of s plus 5 minus ln of s plus 6. Correct? If you will just differentiate it, d of what will be the value, 1 upon s plus 5 minus 1 upon s plus 6. Correct? Now if we know the differentiation, if the Laplace transform of the differentiated function, we can get it for the original function also, right? For this function, what is the Laplace inverse? Laplace inverse, so here it will be minus 5t ut minus of e to the power minus 60 ut. So this is for the differentiated part, right? So for this, what will you get? Minus t times x of t. Correct? So for to get the xt function, what do you do? So just divide it by minus 5t ut upon minus t, and then minus or plus it was minus 60 ut by t. So you'll be left with what? E to the power minus 60 minus e to the power minus 5t by t ut. Okay, is it clear? So see, this question was what, it was in the form of ln. It was pretty difficult to understand. So what we have done is, but you know the properties that for the differentiated function you can calculate the Laplace. So if you can calculate for the differentiated function, what you can do is you can use that properties, the differentiated. If for the differentiated function you have the Laplace, right? So you already know that if you're multiplying something in the t, like in the time domain, if you're multiplying t, right? So in the frequency domain, what will happen? You are just calculating the differentiation of that. Clear?
Yes, sir.
Okay. So are you guys able to understand it? Why this is very like a cold session? Like nobody says anything, and it is like, okay. So let's leave it. So similarly, I'm giving you some homework also. So you can have a problem, something like see, you can be given a problem in the form of a different like differential equation, right? Let's for example d2 yt upon dt square minus dy t upon dt minus 2y dt equals to xt. And then you can be asked to calculate, see, you can be asked like if the system is stable, then what will be the what is impulse response? Okay, for the same question, for the same differential question, the second question can be, if the system is causal, then what will be the impulse response? Okay, you already know that how to solve this type of problem. You can directly write this equation as what? S square ys minus ys s times ys minus 2 times ys equals to x. So you can get yx upon x. That is what your the Laplace transform impulse response, right? The system response. Okay, if you get the impulse system response, that will be what? Ys upon x is, if you want to calculate it, will be s square minus s plus 2. That will be hs. You calculate the inverse, you will get the ht. But while calculating the inverse, you have to take care of something, right? If the system should be stable, you have to take care of that j omega should be there in the ROC. If the system is causal, then what do you take care? That t less than 0, whenever you are calculating the inverse, for t less than 0, the ht should be 0. Okay, so these are all things that you should be considering. Okay, for the same equation, differential equation, you can be asked two different type of question. If the system is stable, what will be the impulse like inverse Laplace transform, and if the system is causal, what will be the inverse Laplace transform? Okay, is it making sense to you guys? Yeah, so this type of problems will be there in your exam.
Excuse me, sir.
Yeah.
So the property, I mean the cause for checking the causal, if the function is causal or not, we have to check h of t equals to 0 when t is less than 0. Right?
No, for all the t, for all the function, see, the causal system are those system which are not defined in the left hand side, so which are all defined in only right hand side. So for t less than 0, so here t is equals to 0, for t less than 0, the function should not be having any value.
Okay, sir.
Yeah, and these are all we are just defining for the system. Okay, for the signal the definition is different. I hope you already know. For the signal, this whatever we are discussing, that is for the system. Okay, for a system to be a stable, or see, if stability, if you are talking about a signal, okay, that is just a, for a signal we don't talk the stability, we just talk that with us the signal is integrable or not. If it is integrable, okay, you just call it as a, okay, this signal is integrable. For a system you call it as stable or not stable. Similarly, for a causal system, you call it as, for t less than 0, the impulse response should be not be defined. Okay, and for a, and then in the signal, when you deal with the signal, you deal with the dynamic, whether the it depends on future, past, or present. Depending on those values, you define whether the system, the signal is causal or non-causal, or dynamic or static. Okay, but here we are just discussing about the system. Whenever you are dealing with the Laplace and all, if you have been asked anything regarding the stability or the causality, mostly 99% will just be discussed about the impulse response. If you are discussing about the impulse response or the system response, that is what, then this is talking about the system, not the signal. Okay, because for any system only the impulse response or the system response is defined. Impulse response is what? You are giving some input delta function, and then you are getting some yt as ht. So this is what impulse response. This ht is what? The impulse response of this system. And then you talk about the stability causality of this system itself. This system should be, for t less than 0, this system impulse response of this system should be 0. Then you call it as a causal system. Is it clear? Yeah, I hope this is making sense to you, right? Okay, so let's deal with the last
Yes, sir.
problem uh, of today's session. See, what I was talking about, let's for example, you have been given a very simple s plus 1 and s plus 4. So you have been asked to calculate xt. So this xt can be of three types. One is like right-handed, one is left-handed, and one is like in the both side. If you have been asked to calculate the right-handed inverse Laplace of this xt, okay. So first of all, what you do is you have to calculate the right-handed side signal. Right-handed signal. So right-handed, you have to right-sided. If you have to calculate the impulse response, what will you do? First of all, you calculate, just split it out. If you will split this, you'll be getting A upon S plus 1 plus B upon S plus 4. So if you'll just put A equals to minus 1 in this, you'll be getting A equals to 1 by 3. So it will be 1 by 3 times S plus 1. And then B, if you'll put minus 1 by 4, so again you'll be getting minus 1 by 8. So it will be 1 by 3 S plus 4. Now you need right sided. Okay, so to get right sided, you already know that what will be the impulse response, sorry, the inverse of this Laplace, it will be 1 upon 3 e to the power minus t u of t, because you need right sided signal, right? So and then for this also 1 upon 3 e to the power minus 4t ut. So you can see that this is right sided. Now if you need the left sided, what will you do? For this is right sided. For left sided, what do you do? 1 upon 3 e to the power minus t u of minus t, minus of this, plus minus minus got cancelled, so minus plus 1 upon 3 e to the power minus 4t u of minus t. Okay, this is left side. Now what you need is that should be existing in both sides. If two exist in both sides, one you can take it as a right side and one you can take it as a left side, right? So the first, if you are taking it as a right left side, so it will be 1 upon 3 minus 1 upon 3 e to the power minus t u of minus t, and then plus sorry, here it is minus, right? So here it will be minus 1 upon 3 e to the power minus 4t u of t. So these are on the both side. Are you able to get it? So same Laplace transform can be given to you, and you can be asked to calculate the 3 different Laplace inverse depending upon the ROCs or where the function is defined. Okay, I hope this. So from the Laplace, what are the questions that I have discussed? Those are the important portion that you should be knowing. Okay, and if you are able to know that, you will be able to solve it, the Laplace transform questions. Okay, so the next meeting will be just discussing about the Fourier transform and the remaining portion. See here, I can just give you an idea about the systems also. So from the system, so different types of system can also be asked, because I already told you for a system to be stable or for a causal, right? Similarly, you can be asked whether the system is linear or the time invariant, or okay. So this type of questions will be asked. Let's for example, you have been given a system as x of t square. This is y. So whether the system is linear or not.
It's linear.
It's linear. Whether system is time variant, yeah, time variant, right? Because there's an operation on t. Whether this is causal or non-causal, this is non-causal.
Non-causal, yes.
Okay, so this type of problem also will be there in your exam. So I told you, right, one question each from 1 to 8th week. Okay, so there will be a question on the operation of signals also, where you'll be delaying signal, expanding, compressing, and then what will be the signal, final signal. Similarly, you can be question from the delta function. So from 1 to 8th week, one question. Last 4 week, the Laplace transform and the Fourier transform. You'll be having a bunch of questions, right? Out of this whole 20 questions, 12 questions are from the Laplace and the Fourier itself. So Laplace I have already dealt with. Which type of questions can be coming in the exam? Okay, you must be knowing all those things. Okay, so you should start revising whatever the portion that you are weak or with. You just keep, and Fourier transform, Laplace transform. I already told you all the formula should be there in your mind. Okay, all the properties should be there in your mind. Okay, so I hope this session also will help you so to solve similar type of problem. Okay, yeah, most important portion are Fourier transform and the Laplace transform, because those were in the last 4 weeks, so those are the most important portion. Yeah, Okay, so you can, in the Wednesday session, you can just come up with all your doubts also. If you have any, you can just revise it, everything. You can come up here all your doubts on the Wednesday session. We'll try to discuss there. We'll try to solve some problem, which I feel is important also. Okay.
Yes, sir. Okay, sir.
Yes, sir.
Okay. So then let's meet it on Wednesday session. And yeah, and any doubts that you have, you can just put it on the G space that we have. Try to put it there. We'll try to solve all the doubts that you have. Okay. Okay. Chalo. Okay. Bye bye. Have a good day.
Thank you, sir.
Thank you. Thanks everyone.
Thank you, sir.
Thank you, sir.
So,